Okay, so you can also make a buffer that works in the basic region of the pH scale. So obviously this will be called a basic buffer. And if you're looking for the ratio for any buffer that contains a weak base and what the hydroxide ion concentration would equal. So the hydroxide ion concentration will be equal to the Kb, and then that will be times the ratio of the weak base to its conjugate acid. Okay, so the hydroxide ion concentration is going to depend on a couple of things here based upon that equation. So the hydroxide ion concentration and the pH of this type of buffer solution depends upon the Kb for the weak base and the ratio of the weak base to its conjugate acid. Okay, so they tell you what this means. If the ratio increases, then the hydroxide ion concentration increases. If that ratio decreases, then the hydroxide ion concentration decreases. And then, can I pull this up? The bottom of the page. If you add a small amount of a strong acid, then however much weak base you have in that solution will react with the hydronium ions or the hydrogen ions from that solution. So here we have our weak base, which is NH3, and then here you have the hydronium ions from the strong acid. So what happens is your hydrogen ions will move in this direction, and then you're going to form the conjugate acid of that weak base and water. Okay, so all of the hydronium ions from the strong acid will now be converted to the conjugate acid of the weak base. So the ammonium concentration goes up and the ammonia concentration goes down. So that means that the ratio decreases. So that's why your hydroxide ion concentration decreases, but it decreases by a pretty small amount. Okay? All right, let's take a look at the next page. Okay, on the next page, right here, if you add a small amount of a strong base, then however much conjugate acid or however much weak conjugate acid you have present, that will react with the hydroxide ions from the base. Okay, so this would be the conjugate acid here, and then this is going to be the hydroxide from the strong base. Your hydrogen ions will move in this direction, and then you will go back and form the weak base and water. So all of the hydroxide ions will be converted to the weak base and water. So since your ammonia concentration goes up and the ammonium concentration goes down, that means that the ratio increases. So the hydroxide ion concentration increases overall, but it increases by a small amount. You can turn to the next page. And the summary for all of this with basic buffers is on the next page. Okay, so right here we've got what happens to the pH if a strong base or strong acid is added to a basic buffer. So in the middle is your equal concentrations of acid and conjugate base. And then, so here is my hydroxide ions being added. So this would be adding my strong base. And then what happens to that is the hydronium concentration falls and the pH rises. And then here you're going to have a larger concentration of your weak base. And then on the right-hand side, when you add your hydronium from your strong acid, here you will have a larger concentration of your conjugate acid. Okay. Okay. Let's take a look at the practice problems at the bottom of the page. Let's look at practice problem number 1. All right, so for practice problem number 1, we've got a weak base, and they want to know what compound and what concentration ideally would make each buffer solution. Okay, so for this one, we've got 1 molar CH3NH2. So I would have the exact same concentration to make our buffer. And then what we can do is we can replace, and you probably wouldn't know this, but nitrogen has a lone pair of electrons. So this is kind of what the structure of this weak base looks like. Okay, so nitrogen can actually accept something else. And what we would typically do is I would add like a halogen to this. So I would make this something like CH3NH3, and then I would put, I would make a note. I would just add a halogen to the substance that we had. And then you're going to add a hydrogen. Halogen has got a -1 charge. And then you're also adding a hydrogen, which has a +1 charge to make this neutral. So this would become NH3, and then I would put a Cl on the end, for instance. I could put something else on it, but Cl is kind of easier. If you're doing this next one here, I would use the exact same concentration. So this is 0.8 molar. And then since it's N2H4, I would add another hydrogen. So that would make this N2H5. And then I would add something else onto the end of it. That one, you could also add something with a -1 charge, like add a nitrate to make it neutral. It's another option. Okay, and then this last one here. And these are really unusual buffer solutions that you're making. So I would not give you something like this, but this is just sort of like guiding you through how to make it. So if this is 0.2, then make it 0.2 molar, and then go ahead and add a hydrogen. So this would become CH3 NH2, and then what I would do, because that's a +1 charge, add something that has a -1 charge again. Doesn't matter, pick a halogen. If you want to add chlorine, you could. If you want to add bromine, you could. They both have a -1 charge to make it neutral. Okay, and then let's take a look at number 2. Number 2 says, write a net ionic equation representing the reaction that happens between a strong acid and a small amount of strong base when they're added to each of the buffer solutions. Okay, so let's just focus on this one. So if I've got CH3NH2 and I'm adding acid, then I would add a hydronium ion here. And then what's going to happen is the hydrogen ion will come over here. And you will end up with CH3NH3 +1 and a hydroxide, right? Or no, H2O. Went too far. Okay. And then for the other one, if you add a base, add hydroxide, the hydrogen will now move in the other direction. So you have CH3 and then NH. I think I wrote the wrong one. I can't remove it from there. I have to go the other direction. Hold on. You can leave the hydroxide. I just had the wrong. This would be CH3 NH3 plus 1 with the hydroxide. So over here I had the weak base. This is the conjugate acid. Hydrogen will move this direction. And then you're going to end up with CH3 NH2 plus H2O. Okay. And then you can look at the next page, and we're almost done. I'm going to stop this video here when you get that all written down.